our most valued student, my name is Confident and welcome to the revision session for analytical geometry, and I'm looking at question number 3, and your ability to approach such questions is very important. If you are to make it in your exam, you need to definitely get hold of this question and see how I approach this one. So just stay tuned and see how you answer some of these questions, if not all of them, and you get your 18 marks. So let's look at this question. It says here, in the diagram below, D, they give you the coordinates of D, as you can see, and then they give you E, the coordinates of E, and F, these are the coordinates of F. There are 3 points on the Cartesian plane. That is basic. So we got that information. Now the first one, 3.1.1, says calculate the length of DE. Now, as I said, it's very important for you to understand how to approach such questions. The first being understanding the formulas. Now, when we come to the formula for length, okay, my writing is strange, but let me try it again. So yeah, you want to write the length, right? Length, when you're calculating length, how do you go about it? So you are saying the formula there, they want the length of DE, right? It is equal to square root of, so you've got your x2 minus x1, then what you do, you square that, plus y2 minus y1, and you square. All right, so everything must be inside the see this thing, okay, it's not, but everything must be inside the square root. Okay, so what you have is something like this. Now it is up to you how you do your x2, your x1 thing. For example, I can go and say for my DE, the D becomes my x1 y1, and the E becomes my x2. See what I do it, y2. So if I say now DE is equal to square root of x2, which is 3, put brackets there, is 3 minus x1 is what? Look at x1, it's negative 3, so it's 3 minus 3 squared. If you do that, the calculator will still give you the answer. Plus, now y2 is minus 5 minus now y1 is 3 squared. You know, they don't penalize you even if you leave it like that. I know you're saying, but this is a plus. To say 3 minus is a plus, it's fine. Just go for the calculator, let the calculator do the work, and the only thing you need to do is to settle the final answer. Are you with me, guys? So that is what you need to do in that case. So when we look into the square root of, if you say 3 minus 3 squared, it will still give you the answer, plus bracket negative 5, I prefer this negative 5, minus 3 squared equal to, you see, I get 10. So you get the answer as 10 units, whatever units those are. You can leave the answer like that. You get how many marks? 2 marks. Not bad. So this question was 3.1.1. Let's keep it like that. You know, some of these questions, you know, they have a follow-up, so you just leave them like that. Calculate the gradient of DE. Now gradient, let's divide further. We come this side. Now we're looking for gradient. Now M, you know the formula for gradient, M of DE is equal to, you've got your y2 minus y1 over x2 minus x1. Some they prefer to say, since I'm looking at D, so this is what some do. They'll be like, okay, my D was what? The coordinates of D was minus 3, just want to show you there, minus 3, and the coordinates of E, it was 3 minus 5. Just want to show you something, 3 minus 5. So you can make this, is allowed to say, this one, remember, it's your X and your Y, and this is your X and your Y. If you want to make it simpler, you can call this your XD, YD, and then your XE, YE. So you can choose to say, when I'm finding the gradient, it will be maybe YE minus YD, see this, all over XE minus XD. See this. It's up to you. You can use this one. It's still fine. There's nothing wrong to that, all right? But whatever case, the answer was still the same. It will be the gradient of DE is equal to y2, which is my YE. It will be, so here, okay, if you are using the version for y, this is what you do. This is your x1, y1. This is your x2, y2. You see that when I'm using that? So the answer will still be the same. As you can see, it will be -5 -3, see that, over, because the y is 3. But look at the second one now. It's 3 minus the minus from the formula and the -3 there. You see that negative, so it's -3. All right, if you are having a challenge with your algebra, I'll say let the calculator do the work. But if you know it, this is same as -8, because minus is you add and maintain the sign. This is plus over 6, you see. So the answer is -4/3. If you're fine working like this, but what do I encourage? I always encourage students, go for the calculator. Why do you want to overthink? Why do you want to expose yourself to errors? Take the calculator and do it. 3 minus -3, you know. Let the calculator do the work. You get the answer. So there is nothing to prove here. You're not proving to us that you know how to do addition and subtraction. Just let the calculator do the work. So what is this one? 3.1.2. This was a 3.1.2. all right, so let's move on. Then they say here, determine the value of k if DEF is 90 degrees. Interesting, the value of k if DEF is 90 degrees. This is what I wanted to say to you. Now when you're working with this question, you must understand, if I can do this, okay, let me make it red. If I can do a line like this, see, and another line from here like that, I need to make it just on top there like this. You must see that these are called perpendicular lines because they told us there is a 90 degree here. So if it's a 90 degrees, it means the gradient, I mean D and F are perpendicular to each other. And you need to know the concept of perpendicular lines, right? What does it say? It says for perpendicular lines, gradient of line 1 times gradient of line 2, I must get a -1. Check the previous videos so for you to be able to remember this. If you take the two gradients, gradient of line 1 and the gradient of line 2, you multiply them. If they are perpendicular, you must get a -1. Meaning, I can take the gradient of D, I multiply with the gradient of F, it must give me a -1. So that's the concept here. So I'll come here and say question 3.1.3. Okay, 3.1.3. So we are saying gradient M of D times M of F, it must give me a -1. But I know M of D. We just did gradient of, okay, DE. Actually, not M of D. It is M of DE, and then my times M of FE. The better one is to say FE because we're talking about a line. Gradient is not a point. So let me correct that. It's DE here and FE because the gradient is not a point, it's a line. So now I know the gradient of DE, which is this one. So in here, I'll take this value here and say what? It's -4/3 times, now I need the gradient of what? FE. So to find the gradient of FE, I come here and say, okay, FE, I know the point. So let me take F and say F is -1k, and then E is what? 3 minus 5. You see what's happening? And then from here, I do the same thing to say gradient of FE. It will be y2 minus y1 over x2. We just did this kind of a thing, minus x1. So what I said is, it's up to you how you want to do it. You can call this your x1, your x2, I mean your y2. You see how I do it? Those errors sometimes they're common. x1, y1, xy, x2, y2. See, so avoid such errors that I was just about to make, which is equal to the gradient of FE. What is it? It's y2, which is -5, minus y1 is k. You see now where we introduce k over. Now what about x2? x2 is 3 what is 3 minus, now minus 1, you see, minus 1. Very important for that. Always be careful of such negative. So it's minus 5 minus k, which is like that. You can't change anything there, over 3 minus minus 1. Remember, minus minus is a plus, so 3 minus 1. 3 minus minus 1 is 3 plus 1, which is a 4. You take this here. We said what? We are looking for the gradient of fe, which is this one here. You see? And then this gradient is the one we are going to put there. Are you with me? So if you look at that, what will I have? It will be times minus 5. Let me use something different like this so that you can see. Minus 5 minus k over 4. This must be equal to negative 1. Do you see what I just did? Then guess what? That's how you solve for k. So in here you can already see that it's easier. Minus 4 cancels. Sorry about this. Let me see what I did there. Okay, that's the 4. So I'm cancelling actually here the, am I cancelling the 4? I think yes, that's what I'm supposed to do. I cancel the 4 here, not the minus 4. I cancel the 4. So what do I have? I have minus 1 over 3. See that? And then times minus 5 minus k over 1 is equal to negative 1. So if I can just bring this thing a little bit this side. Okay, so now the next thing is I need to get rid of what? Now that's where you need to be careful. I need to get rid of this 3. So you multiply by 3 over 1 on the left, multiply by 3 over 1 on the right hand side. You can actually do something interesting. You can actually multiply by negative 3 over 1. So that this 3 goes and that 3 goes. This negative goes and that negative goes. And then you can do the same part. Not to confuse you, just do that. Multiply by 3 so that this goes, that goes. So you have got minus 1 times negative 5 minus k. You see this? But put that in bracket now. Is equal to negative 3. Are you following up? Then from here, what you do? Minus 1 times 5. This opens up now. You are opening that bracket like this. You see? Minus 1 times 5 is 5. And then minus 1 times k is plus k is equal to what? Minus 3. Are you seeing that? And then from there, what do you have? So it's k is equal to minus 3 minus 5, and then k is negative 8. There is our k. So the k value there, the coordinates there, it was actually minus 1 minus 8. See that? Are you with me? And the next one, they are saying, okay, that was 4 marks. 3.1.4, so this was 3.1.3. Now 3.1.4 says if k is negative 8. They actually confirm the answer here, you see. So they're saying if k is negative 8, determine the coordinates of m, the midpoint of df. Now df, the midpoint of df. Midpoint, guys, that's 3.1.4. Let's do that. 3.1.4. They're looking for the midpoint now. Midpoint, remember, is equal to, you can put equal to x1 plus x2. You divide by 2. And y1 plus y2. You divide by 2. That's the midpoint. Is the average of the points. Then it's up to you again to say, what are they talking about? Midpoint of df. D is minus 3, F is minus 1, minus 8. So you bring these points of saying, what is my D? It's minus 3. And what is my F? It's minus 1. We said K was minus 8. Let me just cross check again. D is minus 3. So it's always good to rewrite these points because it helps you to remember. Remember, this is your x1, y1, your x2, y2. Remember this. So that's okay. This is an x. So it doesn't matter whether you call it your xd, yd, your xf, yf, whatever case, it will work. So x1 plus x2, which is minus 3 plus minus 1 over 2, and the other one y1 is 3 plus y2 minus 8 over 2, see, which is equal to, now minus 3 minus this is minus 4 over 2. Remember, it's coordinates, then you put that, it's coordinates. And then 3 minus 8 is equal to 5. No, not 5, negative 5 over 2. You must always remember. You must always remember to maintain it in coordinate form. This into that, it's negative 2. And you can leave it like that as minus 5 over 2 or negative 2,5 actually. Or you can leave it as negative 2 over 5. You can leave it like that. Then this 2 becomes the answer. That is the midpoint. The midpoint. Okay. Okay. Determine. Okay, that is it. Determine the coordinates of M, the midpoint. So if it's in coordinate form, it's usually like this. That's why I'm saying M that. All right. Then the next question say here, determine the coordinates of the point G such that the quadrilateral DEFG is a rectangle. Now let me erase here and see what are they saying here. They are saying determine the what? Determine the coordinates of point G so that the quadrilateral DEFG is a what? Is a rectangle. So if you wanted to make this thing a rectangle, so what you needed was to have a line parallel like this, almost like this, and another line like this. Okay, just to make it similar, let's do this. Let me draw a line on top. That will be just on top there. Just to remember, this thing though is not drawn to scale, but it will be something like this. I'm looking for a line that would be like this here. See, my thing allows me to do that, and then I join those points here. All right, so this is basically that, and you must know how it works. For a rectangle, this point is parallel, these points are parallel. Are you with me? So now let's look at what do we do? Let us look at this part now to say, if we are to look at, says determine the coordinates of point G. Oh, there is the point G here. G is somewhere here, which is G, XY. Let's call it XY. Let's call the coordinates of point G XY. If we are to find the coordinates of what? Of G. What is the best way of going about? Okay, let me think. The first one I got is you can use the distance formula if you want. The distance formula can actually work, whereby you find distance DE is same as distance what? Is same as distance GF, right? And distance GD is the same as distance FE. That is one way. But what if I use the gradient? Okay, let's focus on the gradient. Now look at this one. We agreed that when you are talking about perpendicular lines, remember, when you're talking about perpendicular lines, to say for perpendicular lines, let me just say here before doing something that is gonna take long, but let me see another option. Look at this. We can use actually transformation. Look at this. If I move from here to here, I ask how many steps do I take from here somewhere there to there, right? Remember, we know the coordinates. I'm moving along the x-axis, so this point here is what? Remember, if you go up there, you have got 3. That's the x value. So I want to find out what is this value here. This value here is -1, you see? So what is the distance here that I have to move from -1 to 3? You can see that the distance here is what? -1 to 0 is 1, 1 to 3 is 3, so it's 4 units here. I need to move 4 units, meaning it's 1 here plus the 3 here. So it means 4 units. So the same thing that happens here. If I do this line and I do this line, are you with me? Meaning, remember, it's the same transformation. So to say the distance here, I must do the other way around. The distance here must be 4 units. So the question is, what is this point? This point here is what? It's minus 3, right? So if I go 4 units to this direction, 4 units to the left, it will be what? This point is going to be -7. So you see, there is the x value. So here x is equal to -7. So far so good. Now let us look at the y part. Now the y part is the same thing that I'm following. You look at this distance here, from here to there, to say what is this point along the y-axis. You see, this point is telling us that it's 3 and -5. So you've got -5 here because this is the y value there. See, x and y. So y here is -5. What about here, this point? This point, it was k, remember the y value. So this point is -8. So when you move from -5 to -8, how many steps? You are moving 3 units. You see, downwards. So you move 3 units down. The same thing that you moved here. If you move here, you have to move 3 units down. So the y value was at 3. If you move 3 units down, so it's more like 3 minus 3, it will become 0. So that point will be exactly y is equal to 0. So the y there is equal to 0. So you've got 2 coordinates. Therefore g is equal to -7, 0. Are you with me? So now the question will be, determine the coordinates. How do you do your working? You can simply do this to say for x coordinate. I'll also do another one where we're going to show the calculations just to verify. So for the x coordinates, you are saying 4 units of, okay, 4 units. Okay, let me do this. You're going to say translate, we can say what? You can say translate line, or translate d, which is -3 by 4 units left, right? Therefore x is equal to, what did we say? We said x was -3 minus 4, which is equal to -7. Then do the same thing, y, translate y 3 units down. In this case, we don't say y as such, we say d. Translate d 3 units down. So you're going to say what? 3. So y is equal to 3 minus 3, which is equal to 0. Then you get those coordinates. That was one way you could have done this. Another way you could have done it, it's a little bit long, but I think it can work, where you use the concept of gradients. So the first one is this one, to say I know the gradient of DE. Where is that? DE. There is not length. Gradient of DE, m of DE, there it is. M of DE, it was what? -4/3. Right? So I know the gradient of DE. So I'll write this. M of DE is equal to -4/3. So far so good. And I know the gradient of okay, I know the gradient of DE. That was good. And I know, let me see here, I know the gradient of FE, because I want the gradient of FE. M of FE. M of FE is equal to, let's look at the gradient of FE. You still remember what was the formula for the gradient? There it is. We say it here, look at this, here, m of FE, and we used there. Actually, we did here. This was the m of FE. And we know what is our k. K is equal to -8. So we can come here and say m of FE is equal to -5 minus bracket -8, remember, over 4, which is equal to -5 plus 8 over 4, which is equal to 3 over 4. Does it make sense? Yes. Look at this. I'll show you why I say it makes sense. It's 3 over 4. If you multiply these two, if you say -4 over 3 times 3 over 4, it must give us -1. Look at this. It's -1, meaning these two lines are what? They are perpendicular. You understand? So that's what we are trying to, okay, we are confirming that. But we're not confirming that at this stage. Here, what we are interested on, let me just do this. What we are interested on is to say, okay, since I know this gradient, look at these two lines. Something is interesting. So m of FE is equal to m of GD. Look at these lines. Let me erase now. Here, I don't want to end. Okay, G is, we say it is -70. So look at this. Just to remember, now we are saying this line, and if I draw that line back, draw this line back like this, and I take it out of the way and do this, and I join these points here. You must remember, we also mentioned a perpendicular line. So say this is parallel to this, this is parallel to this. So you must understand now, this is point G. Then parallel lines have got the same gradient, remember? So m of FE is equal to m of GD. So m of FE, which is equal to, there is the gradient, which is equal to m of GD, same gradient. And m of DE, look at the gradient of DE, is equal to the gradient of what? FG. Same thing about parallel lines. These two lines have the same gradient. So FG here, which is equal to FG. Yeah, it's m of FG. Are you seeing that? So this is the way to approach that. So the only thing now is to find what is the gradient of FG. So if G is point XY, now what is the gradient of FG? So you come with G, let's find D, and then let's find E. We are given these points. So what is D? D was -3, right? I'm just trying to show you the longer way that you could have done. E was negative. Okay, GD, do I want that? -3, -5 here, 3, -5. All right, so F, what about point F? Let's put point F also here. But I know F is -1, -8. Okay, let's use these points. So I'm saying, let's find the gradient of FG is equal to y2 minus y1 over x2 minus x1, which is equal to, remember we're focusing on what? F and G. Let's start with x. If this is your x2, so it will be x, start with y. So this is y minus y1. This is the y part, minus 8 over x minus 1. See that? Which is equal to y plus 8 over x plus 1. That's the gradient of FG. Now, what is, if this is the case, we know the gradient of FG though. FG, it is equal to that particular gradient. Okay, let me, FG, yes, there. It is equal to this one. This is the gradient. Gradient of FG is equal to gradient of DE is equal to negative 3 over 4. So it's minus like this. Are you seeing that? So that's the first one. What about the gradient M of what? M of GD. GD is equal to, we have got G and we have got D. So we do the y2 minus y1 over x2 minus x1. Let's start with the x part and y. So it will be y minus 3 over x minus 3, which is equal to, just check with me, y minus 3 over x plus 3. But we know the gradient of GD is the same as gradient of FE, which is 3 over 4, which is equal to 3 over 4. That's it. So that's what you wanted to do. You take now these, you solve for x. These are two equations. So what you're trying to say is, if I'm to work with you, you are saying y plus 8 over x plus 1 is equal to minus 4 over 3. Right? And then you cross multiply here. Cross multiply. 3 times this is 3. Y plus 8 is equal to minus 4 x plus 1. You open up the bracket. Remember, when you open up 3 times y, 3 times 8, which is 3y plus 24 is equal to minus 4 times this and this, which is minus 4x minus 4. Now take x to the other side. You have got 3y plus 4x is equal to minus 4 minus 24. Do you see what's happening there? And then you have got 3y plus 4x is equal to negative 28. That we call it equation 1. See the simultaneous equations? That's what you're dealing with. You do the same thing here that we're doing here, to say cross multiply there. 4 times this, so you've got 4y minus 3 is equal to 3x plus 3. Are you seeing that? Then you open the bracket. Y times these and these and these. 4 times y is 4y minus 4 times 3, 12 is equal to 3 times x, 3x plus 3 times 3 is 9. Take x to the other side. 4y minus 3x is equal to, take this to the 12, is 9 plus 12. Okay, 4y minus 3x is equal to 9, 10, 11, which is 21. This is equation 2. So guys, that's what you needed to solve. Take these two equations, they are the simultaneous equations, and now we're going to say 3y plus 4x is equal to negative 28, and you've got 4y minus 3x is equal to 21. So what you do, this is 1 and this is 2. You multiply. Let's say you want to eliminate x, so you multiply this by 3, you multiply this by 4. Equation 1 by 3, equation 2 by 4. So 3 times 3, you have got 9y plus 12x. Remember, I'm multiplying everything by 3, which is equal to, what is 28 times 3? So you've got 28 times 3. Don't forget the negative sign, of course. Negative 84. Okay, so this is 84. Same thing, this 4 times 4, it's 16y. This time this is minus 12x is equal to 4 times 21, which is 84. So you roll off here, and when you roll off, what you do, you add equation 1 and equation 2. So 9 plus this is 25y. This goes off, is equal to 8 minus 84 plus 84, it's 0. Divide by 25 over 25, there is your y. Y is equal to 0. Then you go to any of the equation. It can be equation 1 here when y is 0. So you've got into 1. So 3 times 0 plus 4y is equal to negative 28. See that? So 4y is equal to minus 28. Am I right? Not for x, actually, for x. Sorry about this. We're looking at the x here. Because y we know is 0. So I'm looking at x. So this is x, this is x, this is x, this is x. So you divide by 4, 4 into 28 is 7. So x is equal to negative 7. So the coordinates, what we have, it's minus 7 and 0. And that point was point G. So that is what they had here. See, G is negative 7, 0. It was too long, but I just wanted to show you other options that you could have done. Okay, guys. Now let's look at this one. C. It says C is a point that and D lies in the second quadrant and there's coordinates that. If the length of CD is that, calculate the value of X. Now they are talking about the keyword there is the length of CD. The moment they say length of CD, I'm told the distance formula. Now to find the length, you still remember the distance formula. CD is equal to square root of what? X2 minus X1 squared plus what? Y2 minus Y1 squared. That's the distance CD. But they told me the CD is 53 units, meaning where they CD it's square root of 53. See here. So this square root of 53 is equal to, then you see how this thing comes. I've got C and I've got D in terms of X. So they want me to find X. So what is C? C is 1 minus 2. So I can put these points and say C is 1, negative 2, and D is what? Look at D. D is X5. You see now? Then you can just substitute here to say is equal to square root. There is an equation. So that's where you have got your X1, Y1, X2, Y2. So it will be X. This is my X2 minus X1, which is minus 1 squared, plus Y2 is 5 minus 2. That's where they try to catch you there. Alright, so square root of 53, you see that, is equal to, and then when you're solving for this now, it's square root of, see, leave out this thing for now, x minus 1 squared. Simplify that with a calculator to just get the final answer. You don't have to stress. So what is this? 5 minus 1? Not 3 of them, 2 of them, squared. What is this? You see, not minus 1, minus 2, sorry. What is that? 49. So this is plus 49. Just do that. Now, you know with algebra, square root on both sides. To get rid of this square root, you square. You come here, you square. But what you do on the left, you do on the right. You square. So there is a square root, there is a square root. It means it just falls off. So you've got now 53 is equal to, now you've got your x minus 1 squared plus what? Plus 49. Are you seeing what's happening? And then from here, you say 53 is equal to, now what is x minus 1 squared? It means it's twice. So this is x minus 1 plus 49. Are you seeing that? And then 53, let's do this, 53 is equal to x times, remember this is the FOIL method, x times x times this times this times this. So you'll have x squared minus x plus 1 plus 49. So 53 is equal to x squared minus x is minus 2x. 1 plus this is plus 50. You're seeing that? Then you take this to the other side. So when you take this to the other side, you will have more like 0, see, is equal to x squared minus 2x plus 50 minus 53. Why? Because I took it the other side. It was positive, becomes negative. See, positive this side, negative that side. So then you can say therefore x squared minus 2x, and then 50 minus 53 is minus 3 is equal to 0. Then you have to solve this. It's a quadratic equation, this one. You can use the quadratic formula. You can solve it like this. This is equal to 0, whereby you put your x here, you put your x here. The factors of 3 is 1 and 3. The bigger number here is negative, so which means the negative belongs to 3, the positive belongs to that. So you see, you've got now x plus 1 equals 0, or x minus 3 equals 0. What is x here? X is equal to minus 1, x is equal to 3. So they gave that. Let's go back to the statement. Let's read again the statement. Where is it? It says C is the point this. The point D lies in the second quadrant. Now, let's make sense now. It lies in the second quadrant and has coordinates x5. Now, second quadrant, what are they trying to say? They are saying if you are finding these, one of the values is correct. So second quadrant is like this. Remember, this is first, this is second, this is third, and this is fourth. So if it's in the second quadrant, you can now try to make sense of these answers to say in the second quadrant it's here. That's the point. And x here is negative. See, going this direction, x is equal to negative, and here x is equal to positive. So the answer that makes sense here is going to be this one. So if you have to find the coordinates of that point, they're saying D, the point, calculate the value of x. X therefore is equal to minus 1. Actually there. So therefore x is equal to negative 1. Alright, so guys, that's how you approach these questions when they are giving you analytical geometry and you're supposed to work them out in your exam. 18 marks, but it's worth it. Guys, remember, subscribe, ensure that you are notified every time I send a new video. You guys are updated. So if you're not subscribed, you're going to lose out. This is the channel with you in mind. By the way, I'm focusing on the underdog, and the underdog is someone who says, I'm struggling with my maths, but if you give me enough time, I can make it. And don't forget, the destiny always belongs to the underdogs, because underdogs always come out on top. But remember, you need to put work, effort. If you're not going to put any effort, unfortunately, there's nothing I can do. Start by subscribing, start by sharing the channel so that you can make sure that others also benefit. And then guess what? You are guaranteed of getting a distinction at the end. See you again next time. Thank you.